Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot, and welcome to SAT and ACT Prep. Today we're going to continue our conversation with operations with numbers between 0 and 1. So remember in math, the really weird stuff happens between 0 and 1, and a lot of things have predictive outcomes that are opposite those that would occur with numbers greater than 1. So we can solve many problems conceptually by imagining or conceptualizing what would happen to the number if it were greater than 1, and then flipping that logic around, considering a number in between 0 and 1. So let me share my screen with you. And again, there is a little bit of a delay because it's a live session, but I'll keep track of that. If there's any questions, just let me know. But the overarching theme here is when solving statements conceptually, we can think of multiplying, dividing, exponentiating, or rooting by numbers between 0 and 1 as having the opposite mathematical outcomes when compared to numbers greater than positive 1. So this is true for multiplication, division, rooting, and exponentiating by a number between 0 and 1. It's not necessarily true if you're multiplying a number that is between 0 and 1 by another value, because we're thinking about logically what would occur if the value would become greater, or if the value is increased by the operation or decreased by the operation does depend on the second value. For example, 1/2 times 4, the 4 is greater than 1, so it's going to increase. If you started with 1/2, it's going to increase to 2. But if you take 4 times 1/2, the 4 will be decreased by the 1/2. So you have to be careful a little bit with your logic there. To solve these problems conceptually, think about what the mathematical outcome would normally be, in quotations, meaning if the number were greater than positive 1, and then just simply reverse that logic to understand what the predictive outcome would be with that same operation done to a number between 0 and 1. So for example, when you're examining the effect of a certain value between 0 and 1, let's say we're examining x squared versus x cubed versus the square root of x versus the cube root of x. So if we make a little chart here, and I'm going to pick two separate values. I'm going to pick if x is equal to, let's say, 8, and let's say x is equal to 1/4. Actually, let's keep it consistent. I'm going to pick 4, x is equal to 4, and then x is equal to its inverse, 1/4. So normally when we square a value greater than 1, we would expect that value to go up. And indeed it does, because 4 squared is 16. So to go from 4 to 16, that represents necessarily an increase. The opposite is true if the number is between 0 and 1. So if we take 1/4 and we square it, we're going to get 1/16. To go from 1/4 to 1/16, that is a marked decrease. If we look at x cubed, so if x is equal to 4 and x is cubed, then we'd have 4 cubed, that's 64. That's definitely an increase, and it's even more of an increase than the squared function. So I'm going to put 2 up arrows to signify that it's a larger increase. The same thing is true if it was 1/4. Well, excuse me, the opposite is true as if it was 1/4. So if we had 1/4 cubed, that would turn into 1/64, which is a much greater decrease. So I'm going to put 2 down arrows. So you can see that the opposite effect is occurring, or the opposite outcome is occurring than we would expect if the number were greater than 1. If we had the square root function, so the square root of 4 is 2. That's a decrease. The square root of 1/4, we can use the distributive property. Let me write this out over here because this is actually very important. The square root of 1/4, we can use the distributive property to say that's the same thing as the square root of 1 over the square root of 4. And then you can just evaluate individually. In the numerator, we have the square root of 1, which is 1. In the denominator, we have the square root of 4, which is 2. So the square root of 1/2 the square root of 1/4 evaluates into 1/2. Notice to go from 1/4 to 1/2 is an increase, which is opposite what we expect with the square root function. And then lastly, if we have the cube root, I'm going to have to get my calculator here. So actually this one is giving me a little bit of trouble. So here, if we have the cube root, let me just do it this way. So if we have 4 raised to the 1/3 power so the cube root of 4 is going to be about 1.59. So that's a decrease, and notice that's even more of a decrease than the square root of 4. If we take the cube root of 1/4, I'm going to evaluate 1/4 into a decimal as just 0.25. And that's going to give us about 0.63. And notice that's even more of an increase than the square root function. So a little bit strange numbers to work there, and I apologize. That's not my normal calculator, and so the fractional exponent, you have to do a second function there. So I apologize for my delay. But as you can see, the opposite relationship or the inverse relationship occurs when it increases when the number is greater than 1, and it increases marginally when the number is in between 0 and 1. The opposite result is going to occur. It's going to decrease marginally. When it increases dramatically, then when the number is in between 0 and 1, the opposite is going to occur, and it's going to decrease dramatically as seen when we compare x squared versus x cubed. The opposite is going to occur, and this is important from a conceptual standpoint because the square root function is a little bit tricky to evaluate mentally. Squared and cubes are a little bit easier because it's just multiplication, but the square root can get a little messy. So to be able to solve it conceptually can help you out a lot. The same thing is true though if we just to imagine what happens to a number greater than 1. So if we take the square root, we would normally expect a value greater than 1 to decrease, as we see here. But when the number is in between 0 and 1, the square root is actually going to increase the value. And then if we increase the index to 3, so we're taking the cube root, then those discrepancies are even more dramatic. So when x is greater than 1, it's really going to decrease. And when x is in between 0 and 1, it's really going to increase. or at least relatively compared to when the index or exponent is equal to 2. If you have any questions, then please let me know. Otherwise, I just want to get right into some practice problems. So I'm going to give you 3 minutes. Please look at number 1, and then I'll give you some hints and the solution. Number 1, I'm sorry, I'm always forgetting to read the question. Number 1 says, if x squared is equal to y raised to the negative 1/5 power, and x is equal to 1/2, what is the value of y? A is 1/2 raised to the negative 10th power, B is 1/2 raised to the negative 7th power, C is 1/2 raised to the positive 7th power, and D is 1/2 raised to the positive 10th power. Excuse me, I'll keep track of the time in the upper right hand corner and update it per minute. Okay, so if we substitute 1/2 in for x, then we're going to get 1/2 squared, quantity squared, is equal to y raised to the negative 1/5 power. If you look at your answer selections, you'll notice that they all are in terms of a base of 1/2. That's a clue that you don't want to change your base. You could evaluate the left-hand side of this equation. 1/2 squared is 1/2 times 1/2, which is the same thing as 1/4. But that's going to change your base. You can always change it back, but you're adding more problems. And if you have the foresight to look ahead at your answer selections, it might save a few steps just so you don't expand out too much. So I'm going to leave the 1/2 as it is. I need to get y by itself. If they're asking me for the value of y, that's just another way of asking me to isolate for y. So the thing that's keeping y from being by itself is that exponent of -1/5. Remember though that when we take a power of a power, if we exponentiate an exponent, then we solve that through multiplication. I can eliminate that exponent of -1/5 by multiplying by -5, because -1/5 times -5, those are inverses of each other, and that will reduce down to just 1, which has no effect on y, so y to the 1 power is just y. So I'm going to raise both sides to the 5th power. Excuse me, the -5th power. So on the left-hand side, I get a power of a power, which is going to be 1/2 raised to the 2 times -5 power is equal to y raised to the -1/5 times -5, which I can write as a fraction as -5/1 power. So notice the right-hand side is going to simplify down into just +1 because -1/5 times -5 is 1. And so I get 1/2 raised to the 2 times -5 power is equal to y. So y is going to be equal to 1/2 raised to the -10th power. So the answer to number 1 was A, 1/2 raised to the -10th. If you have any questions, then please let me know. You can feel free to drop a comment in the live chat function, or if you're watching this recording, you can always leave a comment below. Otherwise, let's look at number 2. Number 2 asks, if x to the 3rd power is equal to y to the -1/3 power, and x is equal to 1/3, what is the value of y? A is 1/3 to the +6th power, B is 1/3 to the +9th power, C is 1/9 to the +6th power, or D is 1/9 to the +9 power. I'll give you 3 minutes and then we'll go through the solution. And I'm sorry, I wanted to no, I don't mean to interrupt, but I do want to make the correction that the exponents here should be negative. So I apologize, that slipped out there. So all of the exponents should be negative when solving. Okay, so if we insert 1/3 for x, then we're going to have 1/3 quantity raised to the third power is equal to y raised to the negative 1/3 power. In order to get rid of that negative 1/3, I need to exponentiate to the negative third, because only negative 3 times negative 1/3 is going to give me a positive 1. And again, I do apologize. All of the answers should have negative signs as exponents. All the exponents in the answer should be negative. So if I multiply on the right-hand side, this is going to turn into just y to the first power, which we know is just y. And then we're going to have 1/3 to the third power, quantity raised to the third power, quantity raised to the negative third power, which is the same thing as 1/3 raised to the 3 times negative 3 power. So that's going to be 1/3 quantity raised to the negative 9th power is equal to y. And that's answer selection B. If you have any questions, then please let me know. Otherwise, let's take a look at number 3. Number 3 says, if 12/5 times x raised to the negative 8 power is equal to 5/3 times y squared, and x is equal to 1/2, what is the value of y? A is 96/5, B is 98/5, C is 106 divided by 5, and D is 124 divided by 5. So same type of process. First substitute in the given value that they provide for x, then use the rules of exponents to simplify, or algebra, to simplify for y. Get y by itself. I'll give you 3 minutes and then I'll give you the answer. Okay, so let me just copy this problem down. So we have 12/5 x raised to the negative 8 power is equal to 5/3 x, 5/3 y squared. Alright, so the first thing, I'm going to get rid of those coefficients. So I'm going to move the 5/3 over to the left-hand side. I'm going to do that by multiplying on both sides by 3/5. If I multiply by 3/5, that's going to cancel out the 5/3. And then multiplying across, I'm going to get 36 over 25. X to the negative 8 is equal to y squared. Now this is tricky because if you take the square root now, which we're going to do, we want y, not y squared. So I need to take the square root of both sides. But you need to make sure that you include everything in that square root. So this is going to be the square root of 36 divided by the square root of 25 times the square root of negative x to the negative 8 is equal to y. The square root of 36 is 6. The square root of 5 is 5. And x to the negative 8 square rooted, that's the same thing as x to the negative 8 raised to the 1/2 power. Remember, taking the square root is the same thing as raising something to the 1/2 power. So that's going to simplify into 6 over 5 times x to the negative 4th power. And now I can substitute in what x is equal to. We know x is equal to 1/2. I'm going to do that up here. So I'm going to have 6/5 times 1/2 raised to the negative 4th power is equal to y. One half to the negative 4th power is the same thing as 2 over 1 to the positive 4th power. That's just flipping the numerator and denominator around. That's literally, you put it under 1, and when you're talking about a fraction, that has the same effect as just flipping the numerator and denominator. So that's really 6 over 5 times 2 to the 4th power. 2 to the 4th power is 16. So we're going to have 6 over 5 times 16 is equal to y. 16 times 6, that looks like 96 to me, but let's see, 16 times 6, yep. So our answer here is going to be 96 over 5. And that's answer selection A. I'm going to leave that up for just a little bit to make sure you have all the work down. If you have any questions, then please let me know. Okay, this guy is from last session. This was the third problem in one of the sets that we didn't get time to finish because at the end of class. But let's go ahead and look at it now. So if negative 1 is less than x, which is less than 0, so pay very close attention to that domain. That means that x is a number in between 0 and negative 1. So it's going to have those opposite outcomes that we were talking about in the beginning of the session, but it's also going to have be negative. So you need to remember that when you raise a number to an odd power, the result is going to retain the negativity. whenever you raise something to an even power, like 2, 4, 6, 8, that's going to eliminate the negativity. So the answer, like negative 2 squared, is positive 4 because the two negatives cancel each other out. But negative 2 cubed is negative 8 because you do negative 2 times negative 2, that's a positive 4. But that positive 4 times that last negative 2 is going to make the overall result always negative. So when you exponentiate to an odd power, it's going to retain the negativity. When you exponentiate to an even power, it's going to eliminate the negativity. So that's going to add an extra little step or extra little characteristic for you to consider when you're answering number 3. But I'll give you 3 minutes and then I'll give you the solution. And number 3 reads, if negative 1 is less than x, which is less than 0, which of the following is or are in ascending order? Statement 1 says 8 to the x power, comma, 64 to the x power, comma, 27 to the x power. Statement 2 says 27 to the x power, comma, 64 to the x power, comma, 8 to the x power. Statement 3 says 64 to the x power, 27 to the x power, comma, and 8 to the x power. Answer selection A is none, B is statement 1 only, C is statement 2 only, and D is statement 3 only. I'll give you 3 minutes. Okay, so looking at this guy, notice that there are only 3 terms to evaluate. Statements 1, 2, and 3 just have them in different orders. So we have 8 to the x power, we have 27 to the x power, and we have 64 to the x power. So this one is a little bit tricky because you kind of, you could use any value for x that satisfies the domain -1 less than x less than 0. So any number in between 0 and -1 would work. But this is particularly written for x is equal to -1/3, because if you take the 1/3 root, if you take the 1/3 power, that's the same thing as taking the third root of a number. So notice that x to the -1/3, we could rewrite that as 1 over x to the +1/3, which we can evaluate. The same thing here, 27 to the negative, if we choose x to be -1/3, then we can evaluate this into 1 over 27 raised to the 1/3 power. And then here we'd have 64 to the -1/3 power. That would evaluate into 1 over 64 raised to the +1/3 power. Remember, raising something to the 1/3 power is the same thing as taking the third root. So we're going to have 1 over the third root of 8, 1 over the third root of 27, and 1 over the third root of 64. I'm going to give you 2 more minutes. Please think about that question, and then I'll give you the solution. Okay, so 1 over the third root of 8. The third root of 8 is 2, so this is going to evaluate into 1/2. The third root of 27 is 3, because 3 to the third power is 27, so this is going to reduce into 1/3. The third root of 64 is 4, because 4 raised to the third power is 64, so this is going to reduce into 1/4. So if we're going in ascending order, going from least to greatest, that's going to be 64 to the x, or in other words, 1/4, 1/3, 1/2, or 64 to the x, 27 to the x, and 8 to the x. That's statement 3 only, which is answer selection D. If you have any questions, then please let me know. Otherwise, let's take a look at the next practice set. So practice set E, question 1, which of the following is or are greater than x if x is equal to 5/8? Statement 1 is 1 over x squared. Statement 2 is x squared. Statement 3 is x to the 1/3 power. Answer selection A is statements 1 and 2 only. B is statements 1 and 3 only. C is statements 2 and 3 only. And D is statements 1, 2, and 3. I'll give you 3 minutes. Okay, so we could take 5/8 and just plug it into each of these expressions and see which of them turned out to be greater than 5/8, the number that we started with. That's always an option that you can just plug in, but let's try and solve conceptually here. So let's think about if the number were greater than 1. So again, let's say that x is equal to x is equal to 4, which is greater than 1, versus x is equal to 5/8, which is in between 0 and 1. If x were greater than 1, like 4, then 1 over x squared would turn into 1 over 4 squared. That would be 1/16. That is definitely a decrease from 4. So a number in between 0 and 1 is going to have the opposite effect. So it's going to actually increase. So I know that statement 1 is true. Statement 2, if I put in 4 to x squared, a number greater than 1, I get out 16. That's definitely an increase from 4 to 16. So if a number is in between 0 and 1, the opposite is going to occur. That's going to decrease or be less than the original value. So I know that statement 2, x squared, has to be false, because if the number is in between 0 and 1, it's going to go down. And x to the 1/3, x to the 1/3 is the same exact thing as the third root of x. So if I take the third root of 4, that's going to decrease 4. It's not going to be an exact integer value, but it's going to be 1 point something. So to go from 4 to 1 point something, that's a decrease. So if the number is in between 0 and 1, the opposite is going to occur. That's going to increase. So your answers here are going to be statements 1 and 3 only, which is answer selection B. But again, if you were at a loss there, you could always just plug in 5/8 and evaluate, assuming that this was on a calculator aloud section. If you have any questions, then let me know. Otherwise, let's look at number 2. Number 2 reads, which of the following is or are greater than x if x is equal to 1/8? Statement 1 says 1 over x to the negative third power. Statement 2 is x to the 2/3 power. And statement 3 is x to the negative 1/3 power. Answer selection A is statements 1 and 2 only. B is statements 1 and 3 only. C is statements 2 and 3 only. And D is statements 1, 2, and 3. I'll give you 3 minutes and then we'll go through the solution. Okay, so if we were to assume that x were greater than 1, let's say x is equal to 4, then 1 over x to the negative third power would evaluate into 1 over 4 to the negative third power. 4 to the negative third power, that's going to be the same thing as 4 to the positive third power. Remember, the negative exponent just flips numerators and denominators around. 4 to the third power is 64. So this results in an increase. So if x were in between 0 and 1, this would produce a decrease. The opposite effect would occur. So statement 1 is not true. Statement 2, 4 to the 2/3 power, that's the same thing as the third root of 4 squared. That's going to be the third root, of 16. So if you take the third root of 16, that's 2.5. So notice that's a decrease. So if it's in between 0 and 1, the opposite effect is going to occur. That's going to be an increase. So statement 2 is true. And looking at our answer selections, there's no answer that contains 2 but doesn't contain 1 other than answer selection C. So if you were taking this test, you wouldn't have to go any further than this. You would know that C is correct. But let's go ahead and test this. 4 to the negative 1/3 power, that would be 4 to the negative 1/3. That's going to be 1 over 4 to the positive 1/3. That's 1 over the third root of 4. The third root of 4 is about 1.58, so 1 over 1.58, that's about 0.63. So this is definitely a decrease overall. So this is going to be an increase if the number is between 0 and 1. So statement 3 is also true. So your answers here would be statements 2 and 3 only. If you have any questions, then please let me know. Otherwise, let's look at question number 3. 3 asks, which of the following is or are greater than x if x is equal to 9 over 16? Statement 1 says Statement 1 says x raised to the 3/2 power. Statement 2 is x raised to the 1/2 power. Statement 3 is x to the negative 2 power. Answer selection A is statements 1 and 2 only. Answer selection B is statements 1 and 3 only. C is 2 and 3 only. And answer selection D is 1, 2, and 3. I'll give you 3 minutes, then I'll give you the solution. Okay, so again, I'm just going to imagine that x, or assume that x is greater than 1, and I'm just going to pick x being equal to 4. And then to evaluate if x is in between 0 and 1, I just flip that logic around. So if x was 4, then we would have in statement 1, 4 raised to the 3/2 power. We can convert this into a radical because the denominator of the exponent becomes the index value of the radical. So we're going to have the square root of 4 to the 3rd power. That's the same thing as the square root of 64, which is going to evaluate into 8. So if x were greater than positive 1, this would be an overall increase. So because this is in between 0 and 1, this is going to overall have a overall decreasing effect. Statement 2, 4 to the 1/2 power is equal to the square root of 4 to the 1st power, which is the same thing as just the square root of 4, which would evaluate into 2. To go from 4 to 2 is overall a decrease, so if the number were in between 0 and 1, that would result in an overall increase. And if we're looking for values that are greater, so statement 1 would not be true, statement 2 would be true so far. And looking at our answer selections, that means that C has to be the answer because that's the only one that contains 2 but doesn't contain 1. But let's just go ahead and check. X to the negative 2 power. If x were 4, then we'd have x to the we would have 4 to the negative 2 power, which is the same thing as 1 over 4 to the positive 2 power, which would turn into a 1 over 16. That's obviously a decrease. So if x is in between 0 and 1, that's going to result in an increase. So statement 3 is also going to be true. So the answer here is going to be C, statements 2 and 3 only. If you have any questions, please let me know. Otherwise, let's look at practice set F. So number 1 says, if x is equal to 2/3, then which of the following is or are less than x? Statement 1 says x minus 2. Statement 2 says x plus 2. Statement 3 says x divided by 2. Answer selection A is statements 1 and 2 only. B is statements 1 and 3 only. C is statements 2 and 3 only. And D is statements 1, 2, and 3. I'll give you 3 minutes and then we'll go through the solution. So remember, those relationships between the inverse relationships, that if a number were greater than 0 versus a number in between 0 and 1, that has to do with multiplication, division, exponentiation, and rooting. Here, for statements 1 and 2, we have addition and subtraction. So remember that those relationships are not going to stand. You have to actually test those values out. So 2/3 minus 2, we can rewrite that as 2/3 minus 2 over 1. You can write any whole number as a fraction by just putting it over 1. And then I need to get common denominators in order to subtract these values from each other. So if I take the second value and multiply it by 3 over 3 to give it a denominator of 3, then I'm going to have 2 over 3 minus 6 over 3, which is going to give me negative 4/3. Negative 4/3 is definitely less than 2/3. So statement 1 is true. Statement 2 is not going to be true just from conceptual analysis. Notice that we have a positive number, which is 2/3, plus another positive number that has to equal a greater positive value. But let's go ahead and test it anyway. If we have 2/3 plus 2, I can rewrite that as 2/3 plus 2 over 1, which I can multiply by 3 over 3 to get a denominator of 3. So that's going to be 2/3 plus 6/3. So that's going to end up being 8/3. 8/3 is greater than 2/3, so statement 2 is not true. Looking at my answer selections, I know that my answer has to be B, because that's the only answer selection that contains 1 but does not contain statement 2. But let's go ahead and test statement 3 anyways. So we're going to have 2/3 quantity divided by 2. I can rewrite that as a fraction as 2/3 quantity divided by 2 over 1. When I divide a fraction by a fraction, you keep the numerator the same, change the operation from division to multiplication, and take the reciprocal of the denominator, meaning that you flip the numerator and denominator around. So the 2 over 1 is going to turn into a times 1/2. Going numerator times numerator, 2 times 1 is 2. Over denominator times denominator, 3 times 2 is 6. And that's going to reduce down into 1/3. 1/3 is definitely less than 2/3. So statement 3 is true as well. If you have any questions, then please let me know. Otherwise, I'll give you 3 minutes. Please look at number 2. Number 2 asks, if x is equal to 1/5, then which of the following is or are less than x? Statement 1 says the quantity x minus 2 divided by the quantity x plus 2. Statement 2 says the quantity x plus 2 divided by the quantity x minus 2. Statement 3 says x raised to the third power. Answer selection A is statements 1 and 2 only. Answer selection B is statements 1 and 3 only. Answer selection C is 2 and 3 only. And answer selection D is 1, 2, and 3. I'll give you 3 minutes and then I'll give you the solution. So we could plug in 1/5 and evaluate here, but notice that in the numerator, for statement number 1, we have x minus 2 when x is 1/5. That's going to be a small number minus a relatively large number over a small number plus a relatively large number. Now the small plus the large, that will stay positive, but a small minus a large is going to turn into a negative. This is going to be a negative divided by a positive, which must always return a negative result. So if x is equal to positive 1/5 and the answer to this expression is a negative value, then the answer must be less than 1/5. The same thing is true for statement number 2. On the top, we're going to have a small number plus a large. That's fine. That has to return a positive value if they both start off positive. But in the numerator, we're going to have a small minus a large. A small minus a large will always produce a negative value. A positive divided by a negative will always produce a negative. So statement 2 has to be true as well. So far, either the answer is A or D, because they're the only ones that contain both 1 and 2. Statement 3 is going to be 1/5 to the third power. Normally, if we raise something to the third power, we'd expect it to go up, but this is a number in between 0 and 1, so we know it's going to actually go down. So we know conceptually that 1, 2, and 3 are all true. If I go ahead and just evaluate here to make sure, I'm going to get 1 to the third power divided by 5 to the third power. 1 to the third power is 1. 5 to the third power is 5 times 5 times 5, or 125, which is definitely less than 1/5. 5 times 5 is 25. 25 times 5 is 125. If you have any questions, then please let me know. Otherwise, I'm going to give you 3 minutes. Please look at this last problem. Number 3, if x is equal to 2/5, then which of the following is or are, oops, I'm sorry, dropped my pen. If x is equal to 2/5, then which of the following is or are greater than x? Statement 1 says x squared minus 2, quantity divided by x squared plus 2. Statement 2 says the square root of x plus 2, quantity divided by x squared plus 2. And statement 3 says the cube root of x divided by the square root of x. So I'll give you 3 minutes, and then I'll give you the answer, and this will take us up to the end of class today. Okay, so if we think about these statements, for statement 1, x squared minus 2, notice that x squared minus 2, x squared, normally squaring is going to increase a value, but this value is in between 0 and 1, so it's actually going to decrease. 2/5 is already smaller than 1, so when we subtract away, first of all, when we decrease it by squaring it and then subtract away 2, this is going to turn into a negative value, whereas the denominator is going to remain positive because it's going to be a number in between 0 and 1 plus 2, which is going to remain positive. But a negative divided by a positive is always going to be negative, so statement 1 cannot be true. Statement 2, we have to actually test because there's no way, it's not clear that it's going to go negative because they're just adding by 2 in the numerator and denominator. So we'd have to actually test 2 and 3 out. So I'm going to evaluate 2/5 into 0.4. If you take 2 divided by 5, that will give you 0.4. So I'm going to take the square root of 0.4 plus 2 over 0.4 squared plus 2. The square root of 0.2 is going to be, the square root of 0.4 is going to be 0.2. 0.4 squared is going to be 0.16. Oops, I'm sorry, hold on. Let me just check that. I'm sorry, that's not going to be 0.4. The square root, that's going to be about 0.63. Sorry about that. Yeah. Okay, so then this is going to turn into about 2.63 divided by 2.16. And that's going to be about 1.22 rounded. And that's definitely greater than 0.4. So that's true. So every answer selection that has 2 but does not have 1, I can eliminate. And so I know that the answer actually has to be C now, but let's just go ahead and evaluate. So we're going to have the third root of 0.4 divided by the square root of 0.4. From the last problem, we know that the square root of 0.4 is about 0.63, because we've already evaluated that. But let me take the third root of 0.4. That's going to be 0.74 divided by 0.63 is going to be about 1.17. And that is definitely greater than 0.4. So your answer to number 3 was statements 2 and 3 only. If you have any questions on anything that we've done today, then please let me know. Please remember to follow me on my social media accounts that are listed in the description. I do questions of the day that I'll keep, and I'll reproduce questions that are relevant to these lessons that we're currently going through. And also, if you find these videos helpful, please like and subscribe. And thank you guys very much for watching. Tater Tot, do you want to say goodbye to everybody? Come on. You say bye. You say bye. Oh, good boy. Very good. Oh, drop your cookie. Thank you guys very much for watching. I'll talk to you all on on Friday. Today's Wednesday. Remember that tomorrow is the writing skills section. We'll be talking about the remaining rules with commas. So have a great night, and I'll talk to you all tomorrow.